Hello everyone, I am Sr.G. Vignesh, working as an assistant professor in KPR Institute of Engineering and Technology. Today in this video, we are going to see a machine design using a magnet software. So before going to the design, let me know what is magnet software. So magnet software is used to analyze the machine with respect to various analysis such as heat flow analysis, finite element analysis, flux flow analysis from stator to rotor. So when we open a magnet software, the display will be like this. In design, we need to analyze an unit parameters. For setting an unit parameters, you need to select a tool. In the tool, you have to set an units. In unit, you can select various length meters. So when you select a length, it will show you in kilometers, meters, centimeters, like that. So for design, we use basically a millimeter as an basic. So we select an millimeters and then we give an apply and then we close. So to know what status of a circle are drawn, for that we use keyboard input bar. Again in tool, you go for an select an keyboard input bar. When you select an keyboard input bar, it will show you an keyboard parameters. For creating an stator, we need to have an inner radius. For that, you select an circle and then given parameters as 0, 0 center point and 0, 195 as an outer circle. So you will get an circle. So like this, it is for an inner radius. So for outer radius is 240. Here you will get an two circles. One is inner radius, another one is outer radius. I am selected line. So for that, you can go for an angle. So radius is, I have already know that outer radius is 200. So I am giving a 200 as an input. So I am giving a circle radius as 30 degree. For example, so I am giving a 30 degree. So once you give an enter, so before giving given enter, it will enable like this, and then you have to change to an x and y axis to 0, 0. So once you give that one, circle will be formed. So after that, you have to select that circle by using a construction slice arc or line. So once you select that arc, this segment edges will enable. So once you select a segment edge, you can delete an unwanted lines by selecting a selector edge. Okay. So once you deleted the unwanted lines, you can develop your stator surface by selecting this surface. So I'm not going to repeat this process with different angles. So I'm using this one with the help of mirror option available in our software. So once you select a line and then you go for a draw. So if you need to rotate that line with some specific angle, you can specify and rotating angle as 30 degree. So I am giving a specific angle as 60 degree. That means 360 divided by I have given that 6 stator surface. For 6 stator surface, I have given angle of 60 degree for rotation of this line. So with number of copies as, I can enable number of copies as totally 5, because I am having already 1 for 6. So I am giving an apply option. So once the apply option is applied, so you can see in different segmented lines with 5 different lines. So from here I am going to design a stator. For stator design, I need an inner surface. So for that, I am giving a circle again, and then with a radius of 0, 0 as an input, and with an angle of radius of 200, I am giving now as an 45 degree. So once you given 45 degree and given enter, you can escape. So once line is entered, you can give an escape. That line, excess line will be automatically disappear. So if you need to trim this line, we have to select a surface again, like the same process, cutting edges. So once the edges is cutted, so I am going to rotate this line. For rotation, I am using 60 degree with number of copies as 5. So once you apply, you can get a different lines. So here suppose if you are having any open loops, you can examine this model by going for an drawing direct and bad edges. So once you select and search option, so it will enable that there is some bad edges. So here if there is no bad edges, it will show you errorless value, otherwise it will give you an bad edges description. There is no bad edges is detected. So once the bad edges is there is no bad edges appears, you can directly go for an designing and applying a component. Stator. So for material, so you have to assign a material by yourself. So for stator I am giving an copper as an material. So copper 735, it will having some different specific resistivity of coppers we will be having in a library. I am selecting copper 5.77 E7. So after selecting a component, you have to give a distance. So distance is for how much amount of copper has to be filled in a surface. So for that I am giving 20 millimeter as a surface, and then so you don't remove any options, so give and apply. So like this you can select by multiple selection can be done by selecting by pressing and control and then selecting each surface in a mouse. So I can fill my object. So once object is filled, so I can once a multiple option is selected, the name will be assigned by system itself. So you can re-edit after in an object surface, you can re-edit after applying surface. So I am giving an same material. So here I am having surface. So I re-enable your names in different ways. So here I am having an excess surface, that is empty surface. So if you need to examine this model, you can examine by using an examiner model. You can rotate the product and then you can visualize any errors are appear. Rearrange and name by selecting the materials and then I have to give an apply. So once applied, so here I am changing the name as S1, S2, S3. I am having uncoated surface by selecting and control in a keyboard. You can select an uncoated surface, then you can assign a material. So I am giving this surface as a stator surface, this one as an non-magnetic surface. So I am going to select a material as non-magnet. So same distance is applied. Surface inner, outer and outer radius you can see. So I am going to disable this. Select a first component and the last component by selecting a shift component. You can select a multiple component at a single point, and then I am giving a right click and then I am giving a disabling that one. So I am going to examine this model by examine the model in a cross-sectional way, X and Z axis. So you need to zoom that one. So you can select that one and then right click and select, and zoom option can be enabled. So once you see in a cross-sectional view, side view of here you are seeing some line. So this is, we call it as a construction line. So I am going to draw a rotor surface. So for that I am going to move a construction surface to some particular distance. So I am used this distance as 20. So I am going to give I am going to move a construction slice to 21. That means I am giving a 1 mm as an air gap. So I am moved the construction slice to 1 mm above that surface. You can delete an outer surface circles. So if you can draw a new circle by same method how you started an initial design of stator. 2 circles are selected. So I am choosing a total number of rotors as 12. So if you are having rotor as 12 rotor surface, for that I am total of I am giving a 200 comma and a degree as 30 degree. So once you given a value, you can see a line So if you cannot see a line, you can disable your already developed surface by selecting. You can disable. So now you can see a clear surface. So I am going to edit this. Gap between each status will be 30 degrees. So that I am using a rotating angle as 30 degree, and number of slots as 11 copies, because I am having another one copy already. So I am giving, once you are applied, you can get a total 11 different surface. So I am going to assign a component for the rotor surface. So I am selecting a rotor component surface by clicking a control button. I am going to select by using my mouse. I am selecting all the component surfaces, and then I am going to apply a component. So in a component, I am using a rotor component as a magnetic. So you can go for either a ferromagnet or aluminum, alnico, like that you can go. I am using a neodymium as a magnet. Distance I am giving as a 15. So once I am giving apply, so components will be applied. So I am having uneven that means unwanted areas. I can select that one, and then I can give it as a bobbin area or non-magnetic area. I am giving a non-magnetic selected surface as a non-magnetic surface. So we have developed a rotor surface as well as a stator surface. If you need to visualize the stator surface also, you can select a component, and then you can see a visible stator surface. So once you examine the surface by rotating a surface, you can see. So here you have developed a stator as well as rotor surface.